Okay, so lesson 4-4. Now we're on to graphing a function rule. The objectives here would be to graph equations that represent functions. Okay, so problem 1, they want what is the graph of the function rule y equals negative 2x plus 1. And a function rule is really just an equation. So the first thing you always want to do is make a table. Eventually, you're going to learn slope and intercept form, and graphing this is going to be so much easier. But for now, we're going to practice by making a table. Okay, you have y values. Those are going to be your outputs. You have x values. Those are going to be your inputs. But you can choose whichever ones you want. So I put this graph on here because I'm going to graph on that. But usually, you want to pick, if you can pick any x values that you want to pick a couple negatives and a couple positives so that you get a good representation of the whole graph. So usually we start with plugging in negative 2, negative 1, 0, 1, and 2. Okay, if you have an equation and it says graph the equation, you can choose whichever x values you want. So I just made those up. Those are the x values that for most of the time we're always going to check those values. Okay, I'll show you on the next one. Sometimes when you have fractions and stuff, you want to choose x values so that your numbers are going to be whole numbers. But most often, choose some negatives, choose 0, and choose some positives. Okay, so you take this function rule. It says y equals negative 2. So you're going to take negative 2 times your x value. Well, your x value is negative 2. And then you're going to add 1. Okay, so that equals negative 2 times negative 2 is positive 4 plus 1 equals 5. Okay, then you're going to repeat that for every single x value. So your equation is negative 2. Now your x value is negative 1 plus 1. So negative 2 times negative 1 is 3 plus 1 is 4. Okay, we're going to take negative 2 times 0 plus 1. Negative 2 times 0 is 0 plus 1 is 1. I'm sorry, I messed up that last one. Negative 2 times negative 1 is 2 plus 1, that would be 3. Okay, yeah, now we're good. Okay, negative 2 times positive 1 plus 1. So negative 2 times 1 is negative 2 plus 1 would be negative 1. And then negative 2 times positive 2 plus 1, that's going to be negative 4 plus 1, which would be negative 3. Okay, so that's how you get the y values. Now, each of those make an ordered pair. So this first one right here, this first line, if our x value is negative 2 and our y value is 5, we have the ordered pair, and I'm going to put it up here so I don't run out of space. Negative 2, comma 5. Okay, then our next ordered pair is negative 1, comma 3. Then we have 0, 1. We have 1, negative 1. And we have 2, negative 3. Those 5 points will graph. So come over here to negative 2, 5. Put a dot there. Negative 1, 3. 0, 1. 1, negative 1. And then 2, negative 3. Okay, now, we'll, as best as we can, draw a straight line down between them. Now here's the thing, those 5 values are not the only values that represent this function. That's why you pick 5 points and you draw a line through them. So every single point on this line is a solution to that equation. But we only need 5 points to get the general direction of the line, which is why you should always put an arrow on the top and the bottom and make sure you go all the way, like cover your whole entire graph. A lot of people will just do this. They'll go from their first point to their last point, but you're just making a representation of the graph with those 5 points. Technically, it goes forever in both directions. So let's try and graph this one. Now, the equation is y equals 1/2 x minus 1. Alright, so we're going to make a table. Now, if you know you're going to be multiplying by a half, you want to pick numbers that when you divide by 2 are still going to be whole numbers. I mean, you don't have to, but it just makes the graph easier. So we definitely want to have 0. And we definitely want to have some above it and below it. So this time let's go with -2 and -4, and then +2 and +4. That just means, like, so when we multiply by 1/2, we're going to get whole numbers instead of decimals, but it really doesn't matter. So we're going to take 1/2 times our x value, which is -4, and we're going to subtract 1. So 1/2 of 4 would be 2. Half of -4 would be -2 minus 1 more is -3. 1/2 times -2 minus 1. So half of -2 is -1, minus 1 more is -2. 1/2 times 0 minus 1. Anything times 0 is 0. And subtract 1, we get -1. 1/2 times 2 minus 1. Half of 2 is 1. 1 minus 1 is 0. And then half of 4 minus 1. Half of 4 is 2. 2 minus 1 is 1. Okay, so then our ordered pairs would be -4, -3, -2, -2, 0, -1, 2, 0, and 4, 1. Okay, you graph those 5 points, and that represents your line. So -4, -3 is right here. -2, -2 is right here. 0, -1, 2, 0, 0, and 4, 1. Okay, and then we draw a line. So this is linear because it makes a straight line. And again, every single point that touches that line is a solution to the equation. All these points in between. We're just only graphing 5 of them so we can get the direction of the line. Okay, so when you have to graph a function, first make a table, and then get your 5 ordered pairs, and then plot your ordered pairs and draw a line through it. Alright, problem 2, just so you know that these do occur in the real world, let me go to the page here. It says, and I didn't write it down because we're not going to graph this one because the numbers are really big, but it gives you the function rule. Okay, it says the function rule W equals 146C plus 30,000 represents the total weight W in pounds of a concrete mixer truck that carries C cubic feet of concrete. So if you've ever seen those trucks on the road, they're like spinning as they drive, like the top of it. They're like mixing concrete. Okay, so your weight, obviously the truck is 30,000 pounds itself. Plus it's 146 times however much concrete is in there. So it's going to be very large. And if you look at the graph, this is on page 254, it's the same thing. You can still pick numbers, but if you're going to be plugging in concrete, the numbers we want to pick for, if we make it, well, it's still an XY table, but it's actually a W and then C, because those are our variables. You really don't want to pick negative numbers because C represents the amount of concrete. So you're not going to be taking a negative amount of concrete. And even if we just pick 1, 2, 3, 4, 5, that's hardly going to change your graph at all because 1 cubic feet of concrete compared to 2 cubic feet of concrete is hardly any difference. So in this case, the values that they picked were 0 cubic feet and then 50, 100, 150, and 200. And then when they graphed it, obviously their graph wouldn't fit on those little graphs that I gave you. But you do the same thing. You plug this number. No, I'm sorry. These go on the. I switched these variables around. This should be C and this should be W. But you plug these values in for C and you get your values for W. So if it comes from a real world problem, you have to think about, are negative numbers appropriate? And then you want to pick numbers so that, because if your scale is so large, you just want to make sure you have numbers that are actually going to show you a difference. Or you're going to have a graph. If this is your graph, your points are going to be so close together, you're not even going to be able to tell, like, the general direction of the line. So that's all, but we don't actually need to graph. Okay, the next part is continuous versus discrete graphs. So a continuous graph is a graph that is unbroken. So I can show you some examples of those. Like that is a continuous graph. that is a continuous graph. This is usually used when fraction and decimal values make sense, and I'll explain that in the next example. And then a discrete graph is composed of distinct isolated points. So if we just have a point here, a point here, a point here, and a point here, and we don't connect them, oops, I don't know what I'm drawing a diagonal for. Or even if we have like a U-shaped and we have just distinct points. Those are mostly used when you have integer values. Okay, so let me show you what I mean by that. Alright, problem 3, it says a local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown. Okay, so that's that and that. Write a function for each situation, graph each function, and then decide if the graph is continuous or discrete. So right here it says 1 gallon of milk makes 16 ounces of cheddar cheese. So we have the weight of the cheese in ounces depends on the number of gallons of milk. So the more milk you use, the more the weight's going to be. So milk is your independent and weight is your dependent. Okay, so they just chose 5 values. 1, 2, 3, 0, 1, 2, 3, and 4. Because again, in this situation, negative values don't really make sense. You're not going to have a negative amount of milk. So the points they came up with, so if 1 gallon of milk equals 16 ounces, well, if you have 0 gallons of milk, your weight is 0. If you have 1 gallon of milk, your weight is 16 ounces. So every time you take a gallon of milk, you're multiplying it by 16. So there's your equation. Okay, and then it says right here, each cheese wheel costs $9. So they picked the same 5 points. If you don't buy any, it costs you $0. If you buy one, it costs you $9. 2 at 18, 3 would be 27, and 4 would be 36. So you're just taking the number that you buy times 9. So your equation equals the number times 9. Now, here's the graphs. Okay, so they graphed each one. They graphed the ordered pairs. The first one is the one with the milk and the weight. Okay, so they graphed those 5 points. But they connected the lines because you could use a half gallon of milk. If you wanted to use a half gallon of milk, that would be right in here, and this is how much the weight would be. If you wanted to use 1 3/4, that would be right here. So using fraction amounts or decimals amounts are appropriate for the amount of milk. But when it comes to the next graph, when you're selling the cheese, these are the 5 points from the table. Okay, but are you going to sell 1.5 cheese wheels? So at the location of 1.5, that would be right here. So 1.5 would be right here. We could draw up to the line, and that tells you how much money it would be. But he's only going to sell the whole thing at once. Okay, it's like when you sell bikes or toys. You're not going to sell half a toy or half a bike. So in that situation, you just graph the discrete points, and you don't connect the lines because 1.5 doesn't really make sense. 1 3/4 doesn't really make sense. So that's kind of the difference in situations when you have a continuous graph, like here on the left, that's continuous, and a discrete graph here on the right. It all has to do with what the situation is. Okay, and the last part of this is graphing nonlinear functions. So remember, nonlinear is not going to make a straight line. So we want to do the same thing. We want to make a table. We have x and we have y. This isn't a real-world situation, so negatives are appropriate. So again, let's check -2, -1, 0, 1, and 2. And I'm just making up those values. You can check any values you want. But if you don't check some that are positive and some that are negative, you don't always get the full representation of what the graph looks like. And you'll see that especially in this one. Okay, so for y, we're going to take the absolute value of our x value and then subtract 4. So the absolute value of -2 is 2. 2 minus 4 would be -2. Then we're going to take the absolute value of -1 and subtract 4. So that's going to be 1 minus 4 is -3. the absolute value of 0 minus 4 is just going to be negative 4. The absolute value of 1 minus 4, well, the absolute value of 1 is still 1. 1 minus 4 equals negative 3. And then the absolute value of 2 minus 4, the absolute value of 2 is 2. 2 minus 4 is negative 2. Okay? And then we have our ordered pairs. So our first ordered pair is negative 2, negative 2. So we go to that location, negative 2, negative 2, and we put a point there. Then we go to negative 1, negative 3. Negative 1, negative 3. Okay, then we go to 0, negative 4. 0, negative 4. So if you just graph negatives, it kind of looks like your line is going down like this. Okay, but then when we get to the positives and we graph 1, negative 3, and then 2, negative 2, you can see that the graph is coming back up again. Okay, so if the negatives are going this direction, the positives are going this direction. So forget about this little blue piece down here. Okay, that's not actually part of the graph. Absolute values, they make a V. And you're going to learn more about how you graph these without making a table. But you can see why it's important to check positives and negatives. And again, even though it makes two straight lines, it's non-linear because the whole thing doesn't make a straight line. Okay, and one more. We have y equals x squared plus 1. So let's make our table. We're going to choose the same values, negative 2, negative 1, 0, 1, and 2. Okay, plug them in. So negative 2 squared plus 1. Negative 2 squared is negative 2 times negative 2. That's 4 plus 1. That would be 5. Negative 1 squared plus 1. Negative 1 times negative 1 is 1. 1 plus 1 is 2. 0 squared plus 1 is just going to be 1. 1 squared plus 1 is going to be 2. And 2 squared plus 1 is going to be 5. Okay, so let's graph these ordered pairs. We have negative 2, 5. We have negative 1, 2. We have 0, 1. We have 1, 2. And we have 2, 5. Okay, be very careful with these. If I were to blow this graph up, make it real big, actually this is kind of curved. I know it seems like a straight line, but there's actually a little curve to it, and then we want to make sure we put the arrows on the end. The only time you have a straight line like a V, like an absolute V, is when you have the absolute value. Anytime you have something squared, you're always going to have like some variation of a U-shaped. So sometimes they're wider, sometimes they're a little bit more narrow, but it's still not a V. So try and remember that. Absolute values will come to an absolute straight V, okay, with a point somewhere. Anything that's x squared is going to be more U-shaped. Alright, try the lesson check on page 257. This one has 8 problems, but they're pretty short. Maybe just do 1 through 5 on this, and then we can talk about 6, 7, and 8. So practice graphing those, and then we'll just talk about 6, 7, and 8.